this practical session. But before that, I'm introduce myself that my name is Vishal Rathod. I'm a PhD student under the Mohit Tahiliani sir. My research area is on the congestion control technique in the Internet of Things, and for that, I have used the Constant Application Protocol, which is acronym as a COAP. So the basic thing about the testbed and introduction part of the COAP will cover by the Mohit sir. So I will start with this introduction. With the testbed facilities, which are the testbeds that available. So basically, you know that when the people are working in Internet of Things, they usually build some algorithms or protocols, or they want to test their algorithms and protocols thoroughly. So basically, the simulation is one of the approach, but the community ask about how your algorithm or protocol will suitable to the real environment. So for that, either you have to build a test bed by yourself, or you need to look around which are the various publicly the available test beds. So if you build your own test bed, right, that needs either systems or sensors like sky mode or Zolarita mode with various functionality, it will cost you in lakhs, right? And as a student or as a faculty, right, you have to go for grants and build the systems. But if someone will give you a ready-made test bed, right, with all the facility, okay, you just have to use that facility freely and run your experiments and extract the results, then it will be good for the researchers, right? So there are various test beds available. One of the test bed is the Frittata Lab. So I will share my screen. So my screen is visible, sir, right?
Yes, sir, it is visible.
Okay. So one of the lab, most of the researchers and people are using it is Frittata Lab, right? Which is publicly available to all the people. So Frittata Lab is a part of the FIT group, Future Internet Testing. That Future Internet Testing is a one type of group. They build a various test bed publicly or privately. Why I am telling this privately? Because some of the sensors are too much costly. So if they made publicly available, then it will harm them. And see, they are located at remote locations, right? So the regular maintenance should be there. So because of that, some of them test beds are publicly available like Frittata Lab, and some of the test beds like Fed for Fire, right? Then F Interrupt. So many test beds are there that are privately available. So FIT have so many facilities like FIT Wireless for indoor Wi-Fi and 5G cognitive radio. If you want to work on this, you can use the FIT Wireless testbed, Frittata Lab for embedded systems, FIT Cloud for OpenStack, your own cloud, then for indoor Wi-Fi. This FIT Wireless provides the indoor Wi-Fi, this many facilities. And for indoor Wi-Fi, there are two labs, FIT In Lab or FIT NC Lab, INRIA Lab and Norton this. For 5G, R2 and Cortex Lab, Frittata Lab that I will start to explain. And FIT Cloud is for OpenStack and Cloud Lab. So there are so many test beds. This is a URL that this image has to be taken from that. But Frittata Lab provides you a 1,500 plus nodes, around 2,700 approximately, right? And all around the world that users, right, that register for that, 40 plus countries are using this, and 200K plus experiments still run since 2012. So this is the large test bed which is located in France. Okay, in France there are different 6 locations that this test bed is used. So you can see here that in France you can see Lille, Strasbourg, Paris, Saclay, Lyon, and Grenoble. These 6 different locations that they deploy the nodes. Now they didn't they didn't buy a premises for create a lab, specific lab, right? Like suppose they buy a land and then develop the lab and put the sensors. No, what they did is they use the existing premises. So this is a C. I will go to the deployment. So this is the deployment scenario. So you can see this. This is the existing premises or office. So on the floor, right? I mean, below the floor, they deploy the cables and all the things, even the sensors, right? On the ceiling, they also deployed it, the sensors, right? On the side wall, as you can see, we will move to the Lily sites. This is the Grenoble. So as you can see that this is in premises, they specifically create the cube to deploy the sensors like this in the board. And these are the robots mode that I will cover. So these are 6 different sites with 6 different premises to deploy the various types of sensors or nodes with sensors, so you can access it. So basically these sensors are, see, if you go to the market and buy the sensors, right, it will very costly to you. So what they did is they purchase the various part of the sensors and build their own hardware. So these are the hardwares that currently available in this Frittata Lab. Just imagine that if you buy any one hardware or one node, it will cost you around 20,000, and this lab will give you this many nodes freely available for testing. Isn't it amazing? So see, if someone works on Arduino, they have good mastery, or some already people have started working on LoRa 1. So there are some LoRa gateway also deploy on this sites, right? Zolerita Firefly is also there. But one of the most powerful hardware is IoT Lab M3. The most of the people are using it. So this is one type of board, right, that they made by themselves, right? So each and every component they outsource from the vendors, right? Like radio chip, various sensors like temperature sensors, pressure sensors, light sensors, and they build hardware by themselves. Of course, it is because of the funding from the France government, but it is good that they build this type of hardware, and this hardware is openly available to everyone. And one of the main thing is, if you use the simulation, right, and if you try to run your algorithm or protocol which is very complex, right, then you have to in simulation or in simulator you have to do the optimization, right? Because that hardware means the nodes that are available in simulator, they have very less memory, right? RAM or ROM, you can say that. Because of that your program, your compiler cannot compile your output, and it will be overflow the memory. So this IoT Lab M3 is a very high amount of ROM and RAM, so you can easily run very complex program. Just see this. This is a simple image that LED will blink, right? So many experiments are running on the LED, live experiments. So this type of nodes are available that you can go through this link, freely available to everyone. So let's start with this Frittata Lab. So it is very easy. So Frittata Lab provides you the multiple platform, right? Means various types of boards that we see. You can set a radio environment as per your requirement. You can build a various topology, right? I will show you that Frittata Lab provide you a 3D deployments of the nodes. So you can create a topology by yourself, multiple OSs. Like this Frittata Lab supports Contiki. This is one of the operating system for IoT. Then Riot, real-time operating systems. Then Zephyr is again one of these operating systems that people are using. So multiple OSs also supports by them. What you have to do is, it's a simple. Everyone has a institute ID, right? Email ID. Like I am from NITK, so I have an email ID from nitk.edu.in. So you also have a ID like this from your premises, right? From your institute. You just have to create an account. Just after click on this IoT Lab info, not this. Wait. After click on this, just click on the access the testbed. So this is, I already logged in. Let me log out from it. Okay, log out from it. So see, if this is the first screen that you click on access the testbed, if you have a credential, then you can log in. If not, then click on register for a new account. So it will ask you about the first name, last name, email ID, password, then category. You can select your category, right? Organization name, city, country, and simple motivations. For what purpose are you want to use this premises Frittata Lab? Simple motivation. After sign up, right? It will take hardly 2 to 3 minutes for them to evaluate you, and you will get a mail from the Frittata Lab. So it will give you the password, and then after you have to log in, right? By using your credential. This is your home screen after login. So these are the my experiments. So it will show you the 3 color combinations, like how many still running schedule like this. So new experiment you want to create a new experiment, my resources, and the testbed status. This is a good thing that you know. The testbed status means how many people still are using it, right? Which premises means which site, and how many number of nodes are occupied, because you have to run your experiments on particular sites. So you have to aware about that, which are the nodes available. So you can see this here, from here also, and from another way when you are submitting the experiment. I will show you how, but before that I will give a quick overview of this GUI, so you can well aware about it. So these are this nodes XY coordinate, that's UID. So these are the 7 sites. So this will be the running experiments. Total 45 experiments are still running on it, and for particular time, how much it's completed, 85%, 86%, like this. Then based on the site, you can select it. So these are the properties of the nodes. So out of 1538 nodes, total available is this. These are the occupied, mean busy. These are the unavailable, and these are the dates. So you cannot use this too. So based on that, you can filter it out by particular site, particular architecture, like. So this is, you can download it from here also. It will download the Excel files. So this is the way you can see, and this is your account, password, SSS key, like this. So when you want to run your experiments, right? So after creating an account, first step is create an account. After creating account, you will get the password, log in it using your password. Then you can change it later once you get it. But you cannot run your experiments, right, till now. Why? Because you have to generate a SSH key, right? Secure set connections, like you have to generate your SSH key. So what happened that you are logging to, after submitting your experiments, you have to access those nodes that you use for your experiments. Like you want to see how your node perform, right? Is there any error occurred or not? Or if you want to run any command line interface program, CLI commands, right? You have to log in to particular site. So for that, you have to generate the SSH key on your local system. These are the steps available. So after generating this SSH key, you have to copy this id_rsa.pub key, and then you have to go to this profile account, then go to the SSH key. After going to the SSH key, you have to paste this here. So see, here I have pasted two SSH key. One of is my laptop, right? And one of my desktop system from my lab from NIT. So if you have you want to access from your mobile, laptop, desktop, or any other devices, just you have to generate the SSH key and paste this here. You can generate as many SSH key, not an issue, right? So these are the keys. After pasting it, you have to update it, and then you are ready to go. So now I will show you the design of Frittata Lab. So this is the user perspective, and these are the sites available. So you can access particular sites by using the API commands, either by through API commands, but through that you can use either a web portal like this. You can use the web portal or command line interface tools that I will show you using the HTTP request or web sockets or anything. And each premises have a various number of nodes. So this is the one way to access this. Another way is through SSH. So as I show you that you have to generate the SSH key for particular to log in through particular premises, right? Suppose I want to access the Green Noble site, so I have to do the SSH to the Green Noble site. So at Green Noble site, there is one system, Linux-based system is located, right? You are transferred to that, and from that system, through SSH, you can access to any nodes from that particular premises. So as you can see that they build their own hardware, which having one open node, right? One gateway to transfer the data and the control node, right? The control node, open node, this gateway is like one type of mini computer. They have a microcontroller unit and several USB and like this. These are the open nodes of particular hardware, right? That you are using M3 hardware like this. And this is the control node for CLI commands and like this. So this is the way you can execute. I don't want to explain it this, but it is an open node, gateway and control node. So serial communication will go through some ports that by default it's predefined. So these are the things in the design purpose. How many resources they have? They have so many resources like this. Now one of the main thing is IPv6. This all test beds are run on IPv6 address, not IPv4. So that inside the premises, there are two types of IPv6 address. One is the private IPv6 address and one is the public IPv6 address. So the private IPv6 address is for the inside the premises, the local network. But now you are accessing from remote location, right? So they have to give the permission to you. So always you have to use the public IPv6 addresses. They are predefined. Sorry, they are already predefined. So these are the prefix. You can call this as a prefix. These prefix are predefined for particular sites. As you can see this, if you are using any of these sites, Green Noble, Lily, Sackley, Starsburg, right? You have a particular prefix, right? And these are the subnets for that. So prefix is fixed 2001 660 5307 like this, and 3100 subnets to 317F like this. So premises prefix address is fixed for particular sites. So if you want to access the node, right, you have to use this IPv6 address, right, public IPv6 address, or then after you can access this from this. So now you said that you have a doubt that, okay, how can I know that out of this range, right, which IP address is available to me? Okay, so for that, there is one command. After after login through SSH at particular site, you have to run this command IP-sex root. I will give you the demonstration. Okay, so you will see very good, but I will just give you the overview of that, how can find it. So when you run the IP-sex root, it will show you which are the IPv6 address available to you for that particular site. Right, so this is the IPv6 address. This is a workspace. So these are the OSs they have supported. I already show you that Riot, Contiki, and the OSs. So let's start with this an example, so you can well learn about that. So I will show you the CoAP example, right? So I will give you some overview of the example so you can track of it. That I will use one of the premises of Frittata Lab and deploy some nodes, and one of the node is a border router and some of other nodes are servers. So what they actually did is, we are using a client, right, Python client, that by using the Python CoAP client, we are sending the request to the server, right, through the border router. So border router is used to open the bridge between the client and server, so we can send the request to the server and get the reply from the server, right? So this is the thing that I will demonstrate you, and then after this thing, right, we are accessing the actual resources or sensors that are deployed at the premises through command line interface. So I will show you that how you create the new experiments. So after logging in the particular dashboard, we have to click on new experiment from here or from here, anything, it is the same. So go to the new experiment and give particular name, right, how many minutes you want, and now you have to select the nodes, right? So there are three ways to select the node. First is by using the node properties. So you can select any of the architecture or hardware that I show you. These are the nodes available at particular premises. Select it, select the particular site, anything, and select the number of nodes and add to the experiments, right? If you click on it, it will add it. Now other way is by using the host name and map. So now this is the main thing that I want to show you. That now people are said that how can you deploy, how can you select the nodes? I already show you that Frittata Lab supports the multi topology, how you can share the multi topology like this. So first I will select the particular site. Suppose I want to select the Lily, okay, and I will select the particular architecture. These two things are required, because if you do not select these two things, then it will show you the map of all the sites and all the hardware. So basically this, you have to filter it out by site and architecture, means particular node type, and then just click on view, select nodes and map. Now see, Manish sir, are you able to see it, or is there any difficulty? Manish sir?
Yes, sir. Is it visible, sir?
Yeah, fine, thanks. If you have any doubt in between, please feel free to stop me and ask. Okay, it's not like at the end of the session you can ask me right now. So after filtering out, right, these two, particular site and architecture, and just click on view, select nodes and map, you can see that these are the particular Lily sites, whole Lily sites, right? And all the nodes M3 that have a M3 architecture is deployed. So you can see that there are 3 combinations of colors. If not, let me zoom out it. So it will, you can zoom out. There are 3 colors. One is green. So when you just mouse over it, you can see that particular node ID on the left hand side here, on the left corner. Just see node ID M3-233. Then how can you access the node? .lily.iotlab-info M3 architecture, and it's alive. So you can use it. Orange one, it's a busy, right? Someone is using it. Or red one means it's a suspected, so you can't use it. So this is the way you can select. Now the main thing is it's a 3D image, so it can rotate as per your selection. Suppose I want to create the grid topology, so by this, seeing this, I cannot select it. So what I want to do, I want to facing this nodes on my face like this. Okay, now I want to select the grid topology. How can I select? So see, 1, 2, 3, 4, 5. You can see here all the nodes are added. If I remove it, this node automatically remove. Oh, sorry, it's very risky. See, now it's a grid topology 3x3. So likewise, you can select it from any particular site. You can say that I can use it from any particular sites. Now I want to remove, suppose I want to select the green noble. So these are the, wait, I want to remove it first. So now you can see this is the green noble site. See, in this you can create the 3x2, right? Linear topology, chain topology, straight line. Okay, even you can see that C topology like this. Create by own way. Leon have a very limited M3 architecture. Nantes new sites. They just introduced yesterday the new sites Nantes, but nodes are still deployed. Right? It is under process. Then Paris, you can see here. You can see easily create any like this. Oh, sorry. Then you can see the Scalable. Scalable is only very less number of nodes. So most of the people are using these sites because of, if you want to create a grid topology or half dumbbell, it is a base site. When the Lily is a base site. Starsberg, you can see here. You can also create the grid topology, right? Half dumbbell topology or any topology you want to create. This is a very, so this is the advantage for you. Like this in simulation you can create the topology, right? But in Testbed, how can you create the topology? So Frittata Lab provides you to create it. This is a very good way. Now the next thing is I will show you by using the node properties, by using the host name and map. Now the third is by using the node ID. So you can see that particular select the architecture and site and architecture, and if you remember the node, right, they will give you the things. So you will provide like this 7 to 9, 7, 8, 9 plus 25 like this. You have to provide it and click on the add the experiment, so it will add it. So now for our example of them, right, for Coax, what I will use is I will create the architecture of M3. I will use the Lily sites, and I will use, right, and I will use a, I will create a, I will select the number of nodes 4. One is a border router and other is a server. And then I will click add to experiments. So now the other thing I will show you that how later part that how you can clone it, right? Suppose you have create your algorithm or your protocol, whatever you think in your local systems. Now, if you do XSS, right, at that time they have their systems, right, at the remote site. how you can upload, right, your code, right, to that premises, that systems. That is very difficult. Even I am facing that when I started to learn this Frittata Lab. That how can I run? Because for one of the paper, one of my paper, right, the reviewer asked me that we want a test bed results. Without that, we can't accept it. So for that, I have to learn that how can my algorithm, right, upload on that systems, because it's very difficult. They are giving you the SSH access to run the command line interface, but they are not giving you the permissions, right, to upload your code there. So how can you do it? I will show you later, but this is the things that this node will be added. 4 nodes will be added, right? This 4 nodes will be assigned randomly, right? But if you want to select a particular node, create a topology, you can use any of these 2, right? Suppose I will show you that. Suppose I want wait, I want 1 border router and 3 servers. So what I will do, I will select 1 and add 2 experiments. So that node will be removed from here. Now these 2 are server, again experiments. Now I close it. You can see that. So now if you are using this GUI and if you have a code on your local system, so I will show you that how you can upload it. But this node will be the border router and this node, 2 nodes will be the server. So by using GUI, you can separate it by them, right? Not an issue. But right now I will show you the command line interface. So by using the command line interface, how can you do it? By using this. So by selecting the architecture and site and selecting the number of nodes and add 2 experiments, the system will assign you the 4 nodes randomly. Let's see, name, 6 minutes. Now I will submit the experiments. So now submission is program. Experiment, it will assign a particular ID, experiment ID 278187. Duration is 1 hour, number of nodes. Now this is a status change launching, right? Now when you click on it, you can see that they assign me randomly 4 IDs, 225, 226, 232, and 238. And these are the UID that you want to use to access. These are the nodes. And now the deployment is success. So by using this, you will start, stop, reset it in between experiments. I'm talking about in between experiments. Suppose you want to create your application, on-off application. So what you have to do? You have to manually off some nodes, on some nodes. So if these are the clients, then it's good that you are on-off applications will be created. So client will be on, off, and your topology or your application is on-off applications like this. So you can flash the firmware also, then monitoring profile I will show you. And this is a terminal. You can access it through from here, or if you select the nodes, you can access. If you don't want to, these are the minimum nodes, 4 nodes, but if you have a 10 or 15 nodes, manually doing, it's very difficult. So you will just select those nodes and perform the actions from here. This is the way. Now the main part. Now this experiment is running. Now what we're going to do? We are doing the SSH. So SSH, your username, @ particular site name. See, I have used the Lily site, right? So this font are visible to you, or shall I increase a little bit? Hello?
Sir, it's visible. It's correctly.
Yeah, sure. Okay, thanks. So now SSH, then after your username, then @, then site name .iot-lab.info, right? So SSH and .iot-lab.info, this is the common. This username is also common for you. Now @ particular site you have to do. Now after creating, if you are a first time user, that will ask you about accessing the means by including your SSH key there. So you have to press this here, and then after it will done. So now you can see that Rathod@Lily. So now I have access of particular Lily site at particular system. Now you can see that if you first time user, right, you will get only I8, right? You don't have an IoT lab. So what you have to do, you have to clone the IoT lab GitHub repository. Like you can see that, where is this? Let me search. This is the IoT lab GitHub repository. You have to clone it. I will show you the steps how you can clone it on the local system. Then you can start working on it, right? So I already clone it. So when we go into the IoT lab, you can see this is the parts, right? These are the folders and files are there. You have to go to the parts. By default, it is blank. Okay, if you are a first user, what you have to do? Wait, it is a make. Okay, it's not showing, but you have to shine. I will show you in the local system that you have to type make. Let me clone it on the local system so you can understand it. Now, you have to clone it on your local system. So it will cloning the IoT lab. Now this is the first time user. Okay, so you can see that IoT lab, right? There is no parts inside that. Okay, what you have to do? Make setup. Now you can see that here I am working on Contiki. Okay, so I will clone the Contiki. If you are working on the Riot, you have to clone the Riot. So what I have to do? Contiki. Okay, so now it will set up the parts and clone the Contiki folder inside. Also, the Open Lab is required because all this M3 hardware and files are in this Open Lab. So it will automatically, when you clone a Contiki or Riot, right, and anything, it will automatically clone the Open Lab part. So now you can see here, the parts folder is created. Now, sorry. Now you can see that Contiki and Open Lab. Now suppose you are working in the Contiki or Riot, right? You have your code here in your local system, right? Like this, same Contiki, right? Same Contiki or same Riot, all the files is there. You are working on your local systems, right? Same code is here. You can see that parts Contiki, same code. You have to write your code here, right? Compile, create binary, and upload on the particular site here, firmware. This is the way you can upload your algorithm and code on particular sites. So this is the how I show you that you can use your own code here, upload it and paste it. So this is the way I can close it. So now we move on to that. I will show you the how use the command line interface. So already Contiki is there. So I will go to the Contiki part. Now, what I want to do, I will go to the examples folder because I want to show you that a border router, because we have to select one node as a border router to create the beach, right? Any of the node out of this 4. Okay. So first I have to look into the code. Okay. So go to the example, then IPv6, then see RPL border router is there. RPL is a routing protocol for low power and lossy networks. These are the one of the routing protocol is used in IoT, whether you are using any of the application layer protocol, but routing is done through RPL. So RPL border router, and here you can see that one code is there, a border router.c. I cannot explain detail in border router C, but I will remove that binary file so you can understand that how binary is created.
Hi Vishal, can you hear me?
Yes, sir. I'm here.
Yeah, just wanted to let you know that I have joined.
Okay, no problem, sir.
Whenever you are done with your part, let me know.
Yeah, sure, sir.
Okay.
Okay, thank you. So I will remove this binary. So you can see that now there is no binary here. So you have a C file. Now everyone are aware about the C programming that create the binary, right? You can use gcc filename.c if you're doing the specific output, binary name -o, output name. So here, nothing you have to do. What you have to run the command is make target is equal to. Now I am using the M3 architecture, okay? Because already I selected the M3 architecture, so I can compile the binary using M3 architecture. So what I will select is make target is equal to IoT lab -M3. If you're using the A8, based on your architecture, you have to set the target is equal to then your architecture name, right? Otherwise, the syntax is same, make target is equal to. The architecture type is different. Enter. Now it will compile the binary. I already compiled. When you compile it first time, it will take 2 to 3 minutes. Now you can see the binary is created, right? Same way, I need a server binary. Okay. So what I will do, I will go to this example IoT lab. Sorry. CD IoT lab. Now I will go to I will use the RBM because Contiki using the RBM REST applications for the Coax. So RBM REST example, now you can see that again I have created the same binaries, client and server, with the same command, make target is equal to like this. So if you type make target is equal to like this command, where is it? If you use this command, all the C files that you have will create the binary based on that. So this is the way this 2 binary is already created, but I will only use the server. Now this is the thing. Now what we have to do is, now we have to create a bridge between that. So I will use the TuneShip application that already provide in Contiki, right? Or provided by the sites. TuneShip 60, we create the 2, then linkage with, then attach it, then which node you want to create. The syntax is, so out of this I want to create the 225 as a border router. So what I will do is I will give the name 225 and -p port number is by default 20,000. Then I have to create the IP address for that. Okay, IP address, IPv6 address. So let me show you that which are the IP addresses available first. So let me remove it. So now I will show you that which are the IP addresses available to them. IP-6 root. So I have a C. By using these commands at particular site, this will be listed. So I have a IPv6 address something like this available to me. So I will use it. So I don't waste my time to typing it. I will show you once. This is the command. You can see that sudo tuneslip6.py -v2 -l -a m3225 p port number, and see this is the address that I am using. Then which node number that we want to use, -64. Then I press enter. Now it is waiting for my connections, right? Open the bridge connection in another terminal because I didn't upload the border router code. So what I will do is, once I will upload the border router code, it will show me the IPv6 address. Okay, so let me see you by flashing the border router code. So for that, there is one command. It is a CLI tool, command line interface tool. Wait. On this. You can see that command IoT lab -node. So I will show you the command line interface tools, CLIs. So you can see that these are the command line interface IoT lab authorization. When you are first time running this CLI interface, first you have to do the authorization. The command is IoT lab -auth. Then the command name is like IoT lab -node -u, then your login name, and then after it will ask you about the password. Then you will done for that. Now, any status of the experiments, you can see that. If you want to get the information about your experiments, this is the command. Now, flashing the nodes and starts submitting the flashing the architecture, submitting your experiments. Okay, then all the things will be used the IoT lab node. Profile experiments like create a monitoring profile, power consumption profile, or any profile, right? Radio monitoring profile, you want to use the IoT lab profile. So one of them I am using is IoT lab node. Okay, then before that is a -" update, but now they are used the flash command, flash, so -- place flash. Then this is the path. As you can see that IPv6 border router, the same binary, then link to the particular node at particular site. So now I will press enter of that. If it is successful, then it will show you that 0, it's successful. And you can see that here, once it is showing up to this only. Right? Now, once you upload it, it will show you it started, create a bridge between that, and this is the IPv6 address for the border router node. Right? As you can see that this is the premises IPv6 addresses, right? Default, and this is A573. This is the UID of particular node C. Right? So now your bridge is created. Now let me ping. Is actually working or not? How can you ping it? Nothing. You have to copy this IPv6 address and paste it here and do it. See, it's pinging. My bridge connection is open. Right? Now, what I will do is I will flash server, right? Code on it. Now I will use the server code, same IoT lab -- sorry. Then path of the same that I use that I have a binary. Then accept. First I use the link. If you want to link particular node, you can use -l. But I have a one border router and other servers. What I will do is -e and accept this node. Architecture, site name, architecture, and node number. So accept 225. Other nodes will be my server. So I press enter. Right? So you can see that 226, 232, and 238 are my servers. Okay. Now let me ping any of this. I want to change the UID of that. Let me check the UID of 9573. Let me check. Oh, it's pinging. Now my server is also online. Clear? Now what I will do is I will show you that suppose you are working on RPL and you want to see which are the neighbors and which are the root from that. What you have to do is you have to use the links command. Then you have to use this IPv6 address because we are using this, and you just press enter. So you will show, it will show you that these are all three neighbors because I didn't create any topology, right? If you create the topology, particular topology that I already show you, then it will show you which are the neighbors, which are the neighboring node, and which are the routes if the nodes are far away, right? Then which are the routes to reach there. and you can see that it will show you the particular IPv6 addresses. Now, sorry. Yeah. Okay. Now we will see we are using the client. Which client? Python client. AI Coax Python client to accessing the resources. So first, I will use the AIO Coax client, okay, with one of the node server, right? This is my client. It will send a request to the server, okay, with this particular ID through Coax. Regarding the Coax, I will give you a one-line introduction that Coax is a compressed version of HTTP. So you can all have the functionality of HTTP, but for resource-concerned devices, HTTP won't work. So we use the Coax. So the brief introduction or detailed introduction given by the Mohit sir. So I will give you the Coax. So instead of HTTP, we write the Coax, : IP address, then : port number and well-known code. What well-known code will give you the results that all the available resources that particular node have. When you press enter, it will show you that well-known core tag with CT400 is XML. Test hello resources is there. Title is hello world, length 0. It is a text type of its resource type is RT, resource type is text. Push notification is there, right? Push notification is for publisher subscriber. Then actuator toggle LED is there for rail LED control. Light sensor is there. Pressure sensor is there. This all the sensors is returned output in JSON. Okay. Then gyroscope is there. All the sensors, all the resources that particular node have, right? It will list out it. So I will first send sensors. I want to access the sensor. See, they will give the syntax how you can access it. So sensors/live. So when you press enter, okay, no host to the router. Why? You can see here. By default, my connection is broken. Okay, this will happen when you are accessing the remote site or you have not a reliable connection. So now, again, I have to do the things. So pardon me. That is the flash command. Okay, now it's done. Now again I have to do upload the server code. Once your connection is broken, remember this, you have to do this. So these are the, you can say that disadvantage or not, but it will give you a publicly available, right, to run the test. These are the minimal things. Now, let me take sensors light. See, now the value came 331, again at 330, right? Now I will access the pressure sensor. You can say that pressure sensor is value is common because we cannot trigger the pressure right now. So let me clear it. I will use the zeros. See, the value is different. Clear? Now I will use accelerometer. Okay, difference you can see. Now what happened that this is my client. You can see that AIO Coax client sending the request to the server through the border router. Okay. Now let me test hello. There is one is there. You can see the hello world. Now I want to change the length because it is supported by them. Length is equal to 42. Whether it is giving, yes. You can see that 84. Sorry, 884 is not there. 84. So you can see that 84 is maximum. Okay. So by using this, you can accessing the resources, right? And by using the client, right, you can send the request to the server. This is one of the common example of the CoAP, Constrained Application Protocol, right? If you have a PubSub application, you can use the push notification if you want to work like this. Push notification is when the event when there is a change in the particular state change, right? In any of the sensors, it will give you the idea of that. Means if there any change in the state, it will show you here. Now, if you want to serial communication is also there, but for that you have to enable the serial communication in your code, right, at the server side. So this is the client examples, right, by default. And suppose you want to analyze, how you can analyze, right, the things. Communication is done, but how can you analyze the things? So one of the ways is through sniffer aggregator. Okay, so
Vishal, maybe before you go to sniffer and open up I think you're going to show the CoAP packets in the PCAP.
yeah,
I think it would be better if I give introduction to CoAP, then you show the PCAP, because then the packet format will be intact.
yeah, sure, no problem, sir.
What is your opinion? What do you think is the best?
No. It's the best way, because they have to know that which are the types of messages and all the things.
Yeah.
So yeah. So till then I will generate the PKF file, because if it might be create a problem. So I will generate the PKF file. I will show them to how to generate it, because okay.
Sure. So this can be a logical break, and I can take over if that is possible then.
Yeah, sure, no problem. You can take over.
All right. Okay. Thanks, Vishal.
Okay, so I will stop right now. I will join later to show you about how to generate the PKF files, right? So you can extract it. Till now, you have, if you have any doubt, you can post it in the group chat. So I will answer it. Okay. Thank you.
Sure. Okay. Yeah. So I think Manish is here maybe. So Manish, I can get started.
Yes, sir. Madam, you please continue.
Yes, sir. Good afternoon. Mohit Tahiliani, sir, from NIT Surathkal, and all the participants. Today we are here to listen and learn on leveraging remote test beds for IoT. The technological breakthrough of the Internet of Things drives the emergence of a wide scope of smart IoT solutions in different domains. Advancing the different technological aspects of these solutions requires effective IoT implementations and experimentations. This is widely addressed following low-cost and scalable methods such as analytical modeling and simulation. Our speaker has had a distinguished research and academic career in networking field. Professor Mohit P. Tahiliani is an assistant professor of computer science and engineering at National Institute of Technology, Karnataka, NITK, Surathkal, India, and a member of the Board of India Internet Engineering Society. He obtained his PhD in the area of congestion control mechanisms for the next generation internet from the NITK, Surathkal, India in 2013. His areas of interest include network congestion control, queue disciplines, network function virtualization, deterministic networking, IPv6 deployments, named data networks, and distributed ledger technology. He has executed projects in these areas that have been funded by Intel Technologies India Private Limited, ABB Global Industries and Service Private Limited, Bangalore, Robert Bosch Engineering and Business Solutions Private Limited, FutureWay Technologies Inc. USA. Sir has received the EMC Young Achiever Award in 2015 from EMC Corporation, Bangalore, and the Outstanding Young Professional Volunteer Award of 2021 by IEEE Bangalore section. Sir has contributed to open source projects for more than a decade. A packet scheduler developed by his team at NITK Surathkal to fight the buffer bloat problem got merged in the mainline of the Linux kernel v5.6. He is a member of steering committee of NS3 consortium and a co-maintainer of traffic control and TCP models in NS3. Sir has over 45 plus technical publications in peer-reviewed international conferences and journals. He is a reviewer of IEEE Internet of Things, IEEE Transactions on Cloud Computing, Elsevier Journal of Network and Computer Applications, Computer Communications, InterScience Journals, and many more. On behalf of EC Department of SDS ITS Indore, we welcome Professor Mohit Tahiliani, sir, and invite him to deliver his lecture. Please, sir.
Thank you very much. I hope I am audible to everyone clearly.
Yes, sir.
Yes, sir.
Okay, thank you. So, first of all, thank you very much, Manish and Professor Ritika. Thank you very much for giving me an opportunity to be a speaker in this particular event. And the next thing I would like to do is apologize sincerely, because I was supposed to start this session at 12 o'clock and then hand it over to Vishal maybe after an hour or so, but got an urgent call from our higher administration and had to go there. So these are some limitations of this virtual world. But I'm glad that I'm able to join and share my views. So Vishal has given you already an overview of what is FitIoT Lab. I'm going to give a precursor to it, and that's why my presentation was supposed to be the previous one, but then now it's happening because of this last minute change. So maybe somebody can confirm once my screen becomes visible. Is it visible?
Yes, sir. It is visible, sir.
Yes, sir.
And when I maximize it, you are able to see it, or it just goes
Full
away?
screen, sir.
Okay, just give me 1 minute. I will do the full screen. So, is it full screen for you guys?
Yes.
Or not?
Full screen.
Okay, all right. So, the topic that I have chosen for the presentation, because of this whole event being related to IoT, is how do you leverage remote testbeds for IoT experimentation? I'll give a proper flow in the next slide, but the whole idea is to explain how we can sit in our own labs or in our own offices or at our own home and continue to work on real IoT devices without worrying about procuring them, without worrying about how to set them up. So this is a huge amount of support that's available for the researchers, and I just thought I'll take an opportunity to explain in this particular session how you all can leverage remote testbeds. But before that, I want to throw some light on what is the importance of network experimentation and what are the methodologies that people in general adopt. Then I'll show a case study about experimentation of the protocol that Vishal was telling about. It's called Constrained Application Protocol. In short, many people call it as CoAP. And I will talk about the motivation why this protocol came up. And one of the most important things is that this protocol is standardized by IETF, which is Internet Engineering Task Force. And an official RFC exists for CoAP, which is called RFC 7252. So the entire working of the protocol is specified in detail in that document, which can be searched on the internet with the name RFC 7252. And then what are the features of it? We will see in brief the working of CoAP, and then I'll briefly touch upon one slide, just implementations of CoAP. There are two types of implementations. One category is openly available implementations, for which you have the source code. You can open it up, you can modify the source code, play around with for your research activities. The other one is for commercial implementations, which are closed source. You cannot look at the source code. You have to buy the licenses and then use CoAP. So both kind of implementations are available. And then I will touch upon what are different ways by which people have done experimentation with CoAP. CoAP is one of the most important application layer protocols. So a lot of work has gone into it, and I'm going to talk in detail about CoAP also, because it doesn't make sense for me to just talk about network experimentation without giving you an example of how actually you can use this experimentation strategies that we are talking about here. Okay, so I'll talk about all of these things for the next 40-45 minutes, and then leave maybe last 10 minutes for question and answers, or Vishal to show the PCAP format. So let's get started with network experimentation. Why network experimentation is important? So I have been working with network experimentations. I have been performing network experiments since more than a decade now. It's about like 12-13 years that I have been playing around with networks, experimenting with different types of networks. So these are views totally coming from my experience. What I can say is that experiments that you perform on networks, they give you a wonderful preliminary insight about the protocol performance. Any protocol that you're studying, it need not be constrained application protocol. Of course, we are going to take that as a case study, but you can think of any protocol that is related to IoT or any in general wireless networks. Any network protocol you want to study the performance, you can get the first-hand insights about that performance by performing network experimentations. When you do this work, you will identify the problems associated with those new protocols as well. And that is why it is extremely important, and it's highly recommended that before a new protocol is deployed on a live network, it should be tested, it should be experimented, bugs should be identified, and those should be resolved. Otherwise, you know that where is IoT used today? Where is it not used today is the question. It's used everywhere. Even people want to perform surgeries remotely. So doctor is in a remote place performing a surgery on a patient who is several kilometers away, several hundreds of kilometers away. So when your IoT field is so much tightly related to a human life, you cannot afford to have a new protocol which is not tested, because the failure of your protocol or the poor performance of your protocol can actually be responsible for taking somebody's life because of the way the protocol was designed. It's extremely important to ensure that you identify all the performance problems with the protocols, and network experimentation is your friend. You can actually perform numerous experiments before you come to the conclusion that now my protocol is safe to be deployed in the real field or the production network. It is also very crucial to test the scalability of new protocols. For example, IoT is a field in which billions of IoT devices are going to be connected to each other, and more importantly, when you say IoT, these devices are not going to need human intervention. A refrigerator will talk to and another device, your phone, when, for example, when the amount of milk in your refrigerator is less, you will get an automated message saying that get milk on the way when you're coming back from office. So a device will communicate to a device, and probably human interventions won't be needed. So looking at just the sheer scale of the number of devices that will be connected, we need to ensure that our protocols will be able to operate in such a large environment, and such large number of devices will be supported by protocols. So Coax has been very well tested these days. Vishal was also mentioning about routing protocol for low power and lossy networks. That's the short form which is written in my slide, which is called RPL in bullet number 3. What I'm trying to explain is how do you test your protocols in a scalable way? You have to perform experiments, right? Another thing, sometimes we as researchers, we come up with new protocols and we think that, okay, this protocol can be a breakthrough innovation and can solve a lot of problems. But eventually, when you try to implement that protocol in the real world, when you try to deploy that protocol in the real world, you realize that the deployment complexity of this protocol is very, very high, and it's not feasible to deploy in the real world. Because, for example, let's say you come up with a protocol and that has a tight coupling with IPv6. Now we know that IPv6 deployment is happening everywhere in the world. India is leading from front in IPv6 deployments, but still IPv6 is not deployed in majority of the places. So if you come up with a protocol which has a tight dependency on IPv6, then your protocol cannot be deployed immediately because IPv4 is the current protocol being used. So you need to wait until IPv6 deployment happens all over the place, and probably then your protocol would be more useful for the community. So these experiments can help you to evaluate the deployment feasibility. These experiments can also help to test the protocols in a variety of environments. So for example, IoT, there's no concept only called static IoT. You don't have IoT devices sitting at one place. You might have IoT devices moving from one to another because they are like mobile watches, they are your phones, they can be your tiny IoT gadgets which will be put up on your cars or trucks or trains. So basically there will be so many IoT devices that will have mobility involved. And then it's important for you to verify that your protocol continues to work when the network is mobile or the device is moving from one place to another. So those testings are important, and network experimentation is really crucial. Another thing, how much will be the cost of deploying your new protocols? Is it cost effective? Is it expensive? Those things can be experimented using the network, whatever tools you can use, and then you can come to a conclusion that, okay, the deployment might be expensive, or no, it is just a small patch, and then the deployment will be super fast, and not just fast, but even cost effective. Another part, whenever you ask your network administrators who are in your university or in your industry, if you are from industry, they find a lot of difficulty in managing the campus networks, basically. So that means there will be a network admin in your university who will be managing the entire internet connectivity and network connectivity inside your campus. So network experimentations can help you to manage your big networks. You can create a model of these big networks into a small simulator, test it so that you understand where the problem might be happening, and then you apply that knowledge that you gain from simulations onto the real world to see, okay, yes, this is a problem I was expecting to happen and it has happened and now I can solve it. Another thing, many a times people and students, they ask me, how do you understand a new protocol? It takes a lot of time to read a document. I would always say, you read the documents, that's necessary, but start playing with that protocol in experiments at the earliest. The more you play with your experiments, the more you will get idea about how that protocol works. So, for example, I was seeing right now, Vishal was showing a set of different commands and different possibilities that can be done. It might have been overwhelming for you to look at the way he was performing experiments. He was going fast. He was fast in the sense I'm not giving a feedback on his presentation, but I'm saying he was switching over from one command to another. And some of you might have been looking at that command for the first time and you will be wondering, okay, well, this is not something that I will be able to do because I need time. You need time, of course. And that's why we are going to give you resources. I'm glad these sessions are being recorded. You can watch them again and again. And point is, you need to start working with experiments to gain an idea about the protocols. Computer networks particularly, I cannot speak about other subjects because this subject that I teach and I work on, computer networks is more of a subject in which if you perform experiments, you will get more idea than just reading the textbook or reading the papers. You need to apply what you see and then you will gain more knowledge. So I would always encourage perform as many network experiments as you can. Look at how a real packet looks like. Open up a packet in Wireshark and see how an IP header looks like, or how a TCP or a UDP header or an HTTP header looks like, and that's always more important. And last, every university, whether in India or abroad, has a dedicated lab for networking. Why is that important? Because we want the next generation of students and the manpower to have those skills so that they can perform network experiments. And these skills will be useful in future. For example, if you have IPv6, take a look at what's happening. IPv6 deployments in India are increasing. If you are not aware, let me just bring it to your knowledge that, Ministry of Government of India have brought separate initiatives for deploying IPv6. And there are so many new programs, including funded programs, certification programs that are happening just on IPv6 deployments. So developing manpower on IPv6 is important. Now, how do you develop a manpower on IPv6? You need to put IPv6 network experiments in your curriculum or introduce them in your labs so that students can play more with IPv6 and they'll become familiar. Because you saw Vishal was always using IPv6 addresses, and IoT is one technology where the fundamental protocol is IPv6. So if you suddenly want to now say, okay, no, that means I should know IPv6. Yes, you should know IPv6. How do you know? Perform experiments. Okay. So what are different ways by which people perform experiments? I have listed 4. There can be many. But these are 4 that I have observed in so many years. Number 1, use mathematical modeling, analytical modeling. Okay, you perform mathematical modeling using stochastic differential equations, or you do any other fluid modeling work. You use MATLAB, put your code there, and then start running experiments, and you kind of model the network that you are trying to work with. So, what are the beautiful parts of analytical modeling? The most important part of analytical modeling is that it abstracts the details of the protocols. That means you don't study the protocol in absolute detail, you just work on an abstract level and see on a high level how the protocol is working. And one more important thing can be done in analytical modeling. You can divide the protocol's functionalities into small features, and you can individually test one feature at a time because all other things can be abstracted out. So you can see second bullet what I've written. Analytical modeling is good and it is suitable to evaluate specific features of the problem. For example, you study any routing protocol, whether it is wired network, wireless networks, IoT, mobile ad hoc networks, anything, there's something called neighbor discovery, which I have written in short as ND. Neighbor discovery means if I am a node who wants to form a routing table and know what is the structure of my network, first I need to identify my neighbors. Who are my neighboring nodes? And that's called neighbor discovery. Now, let's say you want to just study neighbor discovery feature of a routing algorithm and not any other thing. Well, analytical modeling can definitely be helpful for you. But as you go forward and you want to now study how these different features, neighbor discovery is just one feature. Root discovery is a totally different feature. So now, if you want to see entire protocol working with all the features together, neighbor discovery, route failure handling, all of these things, if you want to see together, then analytical modeling might become very tedious for you to handle. And that's why we move down to the next point called network simulations. It is lesser abstract than analytical modeling. You have your own copy of network stacks. So for example, we have studied TCP/IP stacks, right? So when you use simulators, simulators have their own TCP/IP stack. You open up NS3 or NS2 or Omnet++ or any other simulator of your choice. You open it and you will see they have a local developed copy of the network stack. They have their own implementation of TCP/IP. So after all, you have the full implementation of TCP/IP. Analytical modeling will not have a full implementation of TCP/IP. It will just have implementation of one specific feature of the entire TCP/IP, and you are just studying that feature in detail. But in network simulation, you have to play with the whole stack. And that's why I always say network simulations are suitable to evaluate the overall functionality of the protocol. So let's say you want to study entire functionality of AODV, DSDV, these are the protocols that you might have heard about, or RPL, which Vishal was mentioning. If you want to study the overall functionality, then simulations are definitely a better choice. There is one more level of depth, which is called network emulations. In network emulation, you only abstract the network characteristics. That means there is no physical wire between two nodes. There is no Wi-Fi real network between two nodes, but actual stacks are used. That means you have an Ubuntu operating system and you have one laptop in which you have this Ubuntu running. You can actually create two virtual instances of TCP/IP stack using network namespaces, and you can simulate a virtual link between these two network namespaces. That means there can be two hosts, host 1 and host 2, both inside your laptop, like two virtual machines. You can think of VMs, right? You can have two VMs running in your laptop, and you are establishing a communication between these two VMs. Between these two VMs, there is no Ethernet cable, there is no Wi-Fi. It is all system memory that is used. And that's why I said network level abstraction is done, but stacks are real. Your VM is a real VM. And you can use any commodity hardware. When I say commodity hardware, you don't need specialized devices to run these network emulations. You can have a laptop, desktop. You can even perform experiments on tabs if the tab configuration is decent. Last category of performing experiments is testbeds, which Vishal was showing you. And in this, there is no abstraction. Stacks are real, networks are also real. There is no simulation, no emulation, no analytical modeling. Everything is live. And this is where majority of us, we face problems, which is testbeds. So you need funding. You need to apply to Government of India funding or some private industries for funding, and then they will fund you. Then you will establish a testbed in your university. But the problem that we face, for example, right now, pandemic, everything stopped. Buses weren't moving, trucks weren't moving, consignments were not moving from one place. So even if you have requested for a hardware to come from, let us say, just your neighboring city, right? All of you are right now, most of you probably are listening from Indore. So let's say now you got something coming from Bhopal. Even that might not happen, which is like just few hours journey, from your place to Bhopal. But it might not happen because of the pandemic. So there are practical issues that come up when we want to set up testbed. We need funding. We need human expertise. Even if you get the hardware, you need people who know how to use that hardware and set up that for you in the university, right? But here is one important opportunity, and that forms the whole topic of my presentation. There are remote testbeds that are available, and they are available for free, and they are available for everyone. For instance, the Fit IoT lab that Vishal was showing you, it has 1,500 plus IoT devices available for your use, and that too totally free of cost. And that's amazing. That means you just need a browser on your laptop to be able to communicate to this testbed, which is put up somewhere in France in 6 different locations, as Vishal said. And you can go to any location and you can select a set of sensors or IoT devices that you want and perform your experiments, download the results and finish. You don't have to maintain the hardware. You don't have to see whether it stopped functioning. You don't have to see whether power supply is there or not. Suppose you keep the same testbed running in your university. What's the guarantee power supply will be uniform? But these people who have set up these 6 testbeds with the amount of funding that they've got from their respective countries or whatever, whoever has funded them, they are managing the hardware. They are taking care of the power supply. They are paying the bills of that particular device running whole day. Okay, so you don't have to worry. Your focus is on research. You are a researcher who is worried about just performing experiments on real network, you do that. That's your job. Your job is not to really worry about buying these devices and do the work. So that's where this whole motivation comes for this talk that I chose. The reason I told Manish I will talk on this is because I'm not sure how many people are aware that such kind of testbed exists. Not just for IoT. Let me tell you one more thing. There are testbeds available for even 4G and 5G. There are testbeds available for Wi-Fi. You can just search Orbit testbed in US. 400 access points in a 20x20 grid are available for you to use. And you just go there. They give you 2 to 3 hours of slot. Go there, finish your experiments. If you want to extend your slots, even that's possible. You say, okay, I need another 2 more hours. No problem. You need to book your slots 1 or 2 days in advance, and then the slots will be available. Go use that slots, download your results, put it in the paper, forget about the whole setup. You don't have to worry about any financial problems or any practical deployment issues that might arise because of your own maintenance. That doesn't mean I'm discouraging you to set up testbeds. That's not the goal. If you do have funding and you have excellent manpower support and you have good technical people around you, and you think they will take care of all this work and you won't be bothered as a PhD student or as a researcher, go ahead and do the testbed. But until you reach that point, let our work not stop. Okay. So Vishal, for instance, has been from day one using this particular testbeds. We submitted one paper to a very popular journal, and that paper came back with a major revision saying that you have done only simulations. Please perform real network experiments, otherwise we will not be able to accept your paper. Now what do? Should I wait for being in a government institution? I should wait for funding. That might take several months. Apply for funding, I get it. Suppose it's a plus point, I get it. Okay, I get it. Then I have to float tenders. Then somebody should apply for that tender. Then I have to find out L1, the lowest person who quoted the lowest price. Then give the order. Then that person will say another 2 months I need to get the shipment. After 2 months I get it. Then I will give it to Vishal. Then Vishal will set it up. By the time the journal people will say, well, submit again afterwards whenever you are done. We can't wait. Technology is growing fast. We need some solutions. So here are solutions. I told Vishal, let's use Fit IoT Lab. Since then, it's been about 3-4 years. Vishal has used Fit IoT Lab extensively. Maybe, he has given 2 to 3 days full talks only on Fit IoT Lab. It's such a big thing to learn. So I would highly encourage all the people who are listening to this talk, if you are working on IoT or planning to work on IoT, please leverage these remote testbeds. They are totally free and wonderful documentation is available. Yesterday, Vishal reached out to me on WhatsApp and said, sir, tomorrow we have to make a presentation to Indore, and today the testbed, I'm not able to connect. I said, so what is the solution? He said, I have written a mail to the support team. Within 5 minutes, support team gave back the solution to Vishal, and then Vishal was able to access the testbed. So they are actively sitting there to help us to see to it that we are able to connect to their testbed and use it. And that's wonderful. Okay. So please explore such kind of things. Now, let me give you an overview of Coax. I'll talk a little more technical details about Coax so that whatever Vishal told you actually makes sense and you understand why he was showing you Coax experiments. By the way, am I coming through clearly so far, or is my voice breaking at any point? Can somebody give me some feedback?
No, everything is perfect.
Okay, thank you. Wonderful. So let's go into Coax. What is the motivation? Why did people think about Coax? Why did IoT community think about a protocol like Coax? Our web traffic is already working fine. We always use Google. We always use these applications on our phone, mobile apps. What is the most important protocol that we use? It's HTTP plus REST, which is called representational state transfer. We have REST APIs. You might have definitely heard about it. These two, HTTP and REST, are very commonly used across the entire internet for communication. They depend on TCP as the transport layer protocol to provide reliability and congestion control. So if packets are lost, TCP will retransmit it. HTTP doesn't have to worry about retransmission because the protocol which is below HTTP takes care of this retransmission facility. So, and basically there are such wonderful features in HTTP such as persistent connections. That means if you are connecting to a server and you're going to talk to that server for a long period of time, you don't have to establish TCP connection, break down TCP connection and re-establish. Persistent connections means once you establish the TCP connection, it remains persistent for some amount of time and any further communication to that server will not require you to have a TCP handshake, the three-way handshake. That won't be necessary. So such kind of features have been put up in HTTP, but unfortunately, HTTP and REST don't directly become suitable for IoT. Why? That's the next bullet. First of all, IoT networks are characterized by low power and lossy networks. Power is less, wireless networks are lossy in nature. Memory is less, computation power is less, bandwidth available on the network is less, and more importantly, that channels are noisy. Packets will get dropped. They are lossy wireless channels. And problem is, TCP becomes too heavy a protocol to operate on IoT. For every message that you have to send to the server, you have to first establish the connection with that server. So imagine to transfer 1 bit of data, because your sensor might have just 1 bit of data to communicate. That sensor might be a binary sensor saying 0 or 1. What is 0 or 1? 0, everything is fine. 1, I detected a thief coming into your house. So it's just a sensor who has to give an alert that I see something fishy. And to send that one alert, first it says, hi, shall we establish the connection first? And you use that three-way handshake, and then you say, oh, by the way, I found out a thief in your house. So imagine how stupid it sounds if I have to exchange 3 messages just to transfer 1 bit of useful data, which says that there is something wrong in the house, somebody is entering there. So, of course, TCP is not the default choice in IoT, and people tend to move towards UDP. We'll come to that in the next slide. And more importantly, IoT traffic is event-based. For example, you might request a sensor, please keep sending me periodically temperature data after every 3 hours. It doesn't make sense to ask temperature every 5 minutes because temperatures don't change in every 5 minutes. So you say every 3 hours, please send me the temperature data. Now that's an event which is going to happen regularly after every 3 hours, and you don't want to establish communication or connection for every 3 hours. Now that doesn't make sense. Okay, so persistent connections are not required. You don't want to maintain a connection for 3 hours or 4 hours. We want to get rid of this total connection establishment process, and that's why we say we use UDP in IoT. So the fundamental question that I have for all of us is, can we have a lightweight application protocol, not as heavy as HTTP and not as heavy as TCP, particularly made for IoT? The answer is yes, and the answer is that's exactly our protocol that we are talking about. It's called Constrained Application Protocol. So let's take a look at the fundamental aspects of CoAP. First of all, it's an application layer protocol for IoT. We call it as constrained nodes and constrained networks. It has been standardized by Internet Engineering Task Force. It's known as RFC 7252. It's being prepared as RFC by core working group. There are many working groups in IETF. It is developed for machine-to-machine communication, or you can call device-to-device communication, which is typically IoT. And more importantly, it provides a request-response model similar to HTTP. Now, you might think, okay, what is this request-response model? It's a very simple model. You know what? You can actually experiment it while I'm talking with you, and you can have fun. So what is request and response? Take a pen and pinch your friend. Take a pen, open it, and pinch your friend who is sitting nearby you. And when you pinch your friend with the pen, that's a request that goes onto your brain, and then your brain suggests that your hand be taken away. So immediately when somebody pricks with a pen or any sharp needle, you'd immediately take away hand. That is a simple request response model. A request came that pinched your body and you take away your body. HTTP follows this model, and the good thing is CoAP also follows this model. So it's similar to HTTP in that regard, but it doesn't have all the complicated features that HTTP has, which are suitable for web traffic, but we can't use that heavy things for IoT. And more importantly, CoAP runs on top of UDP. HTTP runs on top of TCP, like I told in the previous slide. Of course, in IETF, some people have been also suggesting CoAP can also run on top of TCP, and that's another work, and maybe that's a discussion that we can have some other day, because if I go there, then the remaining time will be spent only on that part. But as of now, CoAP is recommended to be used on top of UDP. If you want to use on top of TCP, there are separate RFCs. You might have to read and follow the rules which they have provided, and then you can use CoAP with TCP also. But I wouldn't recommend doing that because TCP is extremely heavy for IoT-like networks. Unless you really need the features of TCP, don't use TCP in IoT. What are amazing features of Coax? First, most important feature of Coax is asynchronous message exchange. What is the meaning of asynchronous message exchange? And what is opposite of it? Opposite is synchronous. Okay, so take a look at this simple example. Assume Manish is my server and I am the client. And I send a request to Manish and he immediately responds to me with the data, what I requested. That's called synchronous message exchanges. What is asynchronous message exchange? When I request something to Manish, Manish says, I have received your request. I'll get back to you with the response. So he did reply to me, but not with the data that I wanted. He just replied to me by saying, I have received your request. I need time to process it. I'll come back to you. And that's what's called asynchronous message, and that's supported in Coax. That means when Coax client is sending a request to the server, it is not necessary for the server to immediately provide the data. It can always give an acknowledgement to the client saying that I have received your request. I'll come back to you later with the actual data. And that functionality is called asynchronous message exchange feature. Another thing, Coax header is very small header. In one of the slides, I have added that header. And it's very small header with bare minimum functionality. And hence, the overhead of processing the header fields is also very less because IoT doesn't have too much of processing capability. So you don't want a complex header. So it's a simplified header. And typical methods which are supported in HTTP like get method. Get is to obtain any data from the server. Post is to put the data on the server. So get is like a read operation. You are asking for the data, not modifying the data. Post is like you're modifying something and putting that data on the server. Put is also equivalent of post with slight differences between post and put. And delete is like you are totally deleting the data. You are requesting the server that this data be deleted. So these are some fundamental methods which HTTP supports. These methods are included in Coax also. And that's why many people call it that Coax has more or less same features like HTTP, but it's much, much lightweight than HTTP. And there are only 4 message types in, you can see last bullet in Coax. Confirmable. Confirmable message means when a client sends a confirmable message to the server, it means client is expecting the confirmation from the server that the message was received. And that's why it's called confirmable. Non-confirmable means client doesn't care. It sends a message to the server and forgets. It doesn't bother whether the server responds or not. So that again depends on the reliability now. Let's say I'm sending a thank you letter to Manish, who is in Indore, and I am in Surathkal in Bangalore. And if it is just a simple thank you letter, I might put it in a normal post and send it to Manish. But if it's a gift which is expensive and I'm sending it to Manish, I can't be sending it through a normal post because there's no reliability. So probably I'll use some reliable courier method, or even better anywhere where I get an acknowledgement that indeed this was delivered to Manish. So confirmable versus non-confirmable. And other 2 messages are straightforward. ACK is acknowledgement, which is given by the server whenever it receives the message from the client and client has requested for that acknowledgement. Because if I as a client say, this is a confirmable message, then you have to reply with an acknowledgement as a server. And reset means anything goes wrong between the connection of the client and server, either party can invoke reset. Means something is wrong, let's reset our communication. So that's the whole thing, and these are only 4 message types that are there in Coax. Now, there are 2 layers in Coax. One, you can see in this diagram on the right hand side, you can see application layer and UDP. So Coax is in between and it has 2 layers. It's called request response layer and there is something called messaging layer. Request response is basically what I taught you. It just manages the interaction between 2 devices, maybe client and server. One is requesting, another one is responding. Messaging layer is the most important one that actually provides you the functionality of asynchronous message. So if you go to the previous slide, the first and the foremost feature that I told you was asynchronous message exchanges. That means when a client is sending a request to the server, server will just give an acknowledgement that I have received your request, but it won't give the actual data which is expected by the client. That functionality is implemented in the messaging layer. And messaging layer, as you can see, it's the one that's going to directly interact with UDP below. Okay, and you can see I have given the bracket in the example. In the bracket, you can see the server may respond to the request from clients later when it is ready. So when a request comes to me and I am the server, and if I'm not ready to reply because I don't have the data available with me, I can always give an acknowledgement to you saying that the request has been received. I will get back to you when I have the data. And that's the feature that entire messaging layer implements. Let's go forward. and take a look at first confirmable messages. So take a look at the top of the slide. These are confirmable messages that are being exchanged. So on the left-hand side diagram, there is a client and server, and right-hand side also there is a client and server. Let's take a look at the pair on the left-hand side, and you can see a message is sent from the client in which it is written CON. CON, Vishal will show you in the packet capture, and this is what he was trying to show, and I said, no, let me first explain. So CON indicates confirmable message, and ID is kind of a sequence number of the message, because multiple CON messages might go from client to server, and server should know whether it's the same request coming or a new request coming. So that's why there's a separate ID over there, which is written in hexadecimal format. So this CON message goes to the server, and server replies with an ACK with the same sequence number. So now client knows if I send 10 confirmable requests to the server, which ones have been acknowledged and which ones have not been acknowledged. So that's why that ID helps a lot. On the right-hand side now you can see I'm showing an unsuccessful transfer because client is requesting for a confirmable message, but server probably did not get the confirmable message properly. Why the server will not get confirmable message properly? Well, between client and server is a wireless communication channel. That channel can be noisy. And that's why the server was not able to interpret the message that was coming from the client. So it just says reset the whole connection. So this is a utility of reset. And you have seen 3 messages in this slide, which I explained in the previous one. Here, I was explaining 4 message types. 3 we have seen so far. We have seen confirmable, we have seen acknowledgement, and we have seen reset. Now let's read these bullets quickly. So we saw confirmable messages. They are used when reliability is needed. That means when the client wants confirmation that the packet was indeed received by the server or not, such kind of messages should be used. If client doesn't care whether server gets or not, and in that case, non-confirmable messages would be sufficient. Okay. Server will reply with an ACK message to every CON message. This is compulsory. Server has to reply with an acknowledgement. And server replies with a reset message if there is any problem. When I say problem can be client sent a message to the server, but server couldn't interpret because of the noise in the wireless channel. This is just one example, but there could be many other examples where problems can occur between client and server can reset, even client can reset. It's not necessary that only server requests for the reset. Quickly moving forward to non-confirmable messages. This is a very simple example. You can see there is no ACK coming back from the server. Client sends the message, forgets it. Spray and pray. Spray the packets into the network and pray that they will reach the server. There is no guarantee. There is no confirmation that's ever going to come back. Nobody is going to tell you whether the packet was successfully received or not. Okay. These messages are used when reliability is not so important. Server doesn't reply to the non-messages, and it is not recommended for you all to use this message. That is, I would not recommend to use non-confirmable messages if your applications need reliability. So if your applications want reliability, that means if packets are lost and you want to ensure that they are retransmitted, please don't use this, because you're not going to know whether your message went to the server or not in the first place. So even if little bit of reliability is needed in your communication, please use confirmable message feature of Coax. Okay, now coming to request response. Take a look at it, and Vishal was doing all of this in his hands-on session. So client is sending a CON message, and along with that, it is sending a GET request and requesting for the pressure data. And you can see there is a token ID. So I have a question for all of you to think. There is already an ID at the top, which is in hexadecimal representation. You can see it's written AA51. Then there is a token also now. And the question is, why do we need ID and token? Think about it. And let me give you a hint as well. Go back to my discussion of asynchronous message exchanges and try to connect why ID and token both are needed, and you will get the answer. I'll leave up to you to explore that. Okay. So you have a CON message going from client to server with a specific ID, and client is particularly requesting for reading the pressure data. How do you know it's a read operation? Because it's a GET. And there is a token associated with this whole packet. On the contrary, the server is now replying with an ACK. It is using the same ID in hexadecimal. It is putting the pressure value 1000, you can see, and it is again replying with the same token which was there in the request packet. This is a simple request response that Coax works with. And that's what Vishal was showing on Fit IoT Lab. He had 2 machines, 2 IoT devices. one treating as a Coax client, another one using as a Coax server. One requesting for the, so he was sending pressure data, I think accelerometer, he was running so many experiments and getting the data from the server. So he was performing this simple request response operation. Okay, now look at that bottom. Bullet discussion is very good. In this request response model, if the server can reply immediately to the con message, then an acknowledgement is sent, and that is what this diagram depicts. Otherwise, the server still sends an acknowledgement message, but it is empty. In this example, you can see along with the acknowledgement, of course, there is an ID in the bracket, but below the acknowledgement, you can see there is 1000 along with the unit over there, right? That value won't be there if it's an asynchronous message exchange. That means only ACK with the message ID will be sent, but the pressure value will not be sent. Later, it will send the pressure value to the client. And that is where we call asynchronous behavior. And that is where the answer remains of the question that I asked you, why you need message ID and token both? Why not one is sufficient? Why do you want separate token and a separate message ID? Think about it. Okay, so this is another example in which now the server is not ready. In the previous example, server was ready, it replied with the acknowledgement, it gave the pressure value also. This is an example in which you can see same con message is sent to the server, get request for a pressure data, only acknowledgement comes. You can see arrow from server to client is just showing acknowledgement. It doesn't have any content. And now when the pressure value is ready, you can see server is sending a con message to the client saying that this is a confirmable message for you and here is the pressure value that you had requested earlier. And now client is sending an acknowledgement to server saying that, okay, thanks, received your values. So you can see this is asynchronous exchange, and that's what I've written on the left hand side. You can see how does server follow up with the client later. That means client requested me something, I'm not ready, I will communicate with the client later. How does that communication happen? This is the example. So server will send a con with the reply if client requested a con, and then client acts the reply. You can see the last message in the timeline diagram on the right side is an acknowledgement coming from the client. So totally here there are 4 messages. Client requests the server, server is not ready, so it just gives an acknowledgement and then remains silent for some time. Once its pressure data is ready, it sends the pressure data along with the con message, and now client has to confirm that it has received this data, so it sends an acknowledgement. And you can see carefully the hexadecimal representation. I'm partially answering my own question, but it's important to give you enough hint, right? Take a look at the message ID in the first con message at the top. It's 0xAA51, and the server has replied with the same acknowledgement, but it has not sent pressure data, it has not even sent the token. And now look at the third message. It's a con from the server and it doesn't have 0xAA51. It has 0xAA52, which is the next sequence number. And then 1000 HPA is a pressure data. Look at that token now. There's a token, red color you can see in the third line. Token which is same as the token that the client had sent. This should now be more than enough hint for you to understand why message ID is important, which is written as 0xAA51, as well as you need a token. Now it should be very clear. Think about it and you should get the answer straightforward. And this is finally coming to the last part of Coax. This is how the Coax package structure looks like. You can see only 2 rows are important. The first one, which is divided into version field, there is a field called type, then there is TKL, that is token length, then the code, and then the message ID, and then the token. Other 2 are optional, basically. So options, if you want, you can add some options, and payload. If any actual data you want to send, you can send that. For example, the pressure data in our previous example, 1000 HPA, that can be put up in the payload here. Let's take a quick look at this slide without wasting too much time. Version bit is 2-bit unsigned integer. Negative values are not permitted. 2-bit means there are 4 possibilities and they indicate the different versions of Coax. Okay, so 0 version, version number 1, version number 2. Like we have an IP header, there is a version field that says this is IPv4 or IPv6. Similar to that, this is a version field in the Coax header. Second one is a type. Just now we looked at the type. There are 4 types: confirmable, non-confirmable, acknowledgement, and reset. So there's a 2-bit unsigned integer, again unsigned because there is no negative value permitted. So there are 4 values, 0, 1, 2, 3, and then 0 is reserved for con, 1 is reserved for non, which is non-confirmable messages, and the last 2 are reserved for reset and acknowledgement. So 4 possibilities are there and 4 message types are there. Finished. Token length. Token length indicates the length of the orange token. You can see there's an orange token row, second row in the diagram at the top. And how much is the length of the token that is specified in the TKL field? And it's a 4-bit field basically. So it can store an integer as large as 2 power 4, which is 16 bits, 16, right? Similarly, on the right hand side, there is a code, and that code is an 8-bit field. Now, what is this code? This code, if you remember, whenever you do HTTP request, you get 200 OK. That means the web page loaded correctly. 404 page not found. 404 page not found. When you try to hit IRCTC during Tatkal time, you will get a 404 error. So you know that 404 error problem is at the server side. 200, well, everything went fine and the file has been received successfully. So these are HTTP codes, and same codes are borrowed in CoAP also. Not much difference is there. Message ID is a 16-bit field which you are seeing frequently here. For example, the message ID is 0xAA51. So that is a message ID on the top right. And token, you saw token also. Here you can see again a hexadecimal representation, 0x14. So that's a token value that sits in the orange bar. And the blue and the purple ones are optional ones. If you have a payload, you send it. If you don't have a payload, for example, take a look at this second arrow from a second arrow in the series from 4. That is ACK, which is going from server to the client, 0xAA51. It doesn't have any payload at all. So there is no payload over there. But look at the immediate third one. It's a con message and there is a payload. You can see 1000 HPA is a payload that is being added over there. So this is how CoAP message formats look like. Now, briefly touching upon the implementations of CoAP, I would recommend everybody to go to this website, which reference I have given in the bottom of my slides. You can see https coap.technology. Just go there and there is a button called implementations and you will get this web page. I have taken a straightforward snapshot of the web page. Go there and you will see so many different implementations of CoAP. Pick up the one that you are most comfortable with. There is one in C, there is one in Java, there is one browser-based implementation. There are so many different ways by which CoAP has been implemented. Pick up the one that you like the most. So this is one, and by the way, on the same web page, you will get 2 categories of CoAP implementations: open source CoAP implementations as well as commercial CoAP implementations. Okay, so now I'm going to the last part of my lecture, and then I think, yeah, it's already 1:51. So let me quickly cover up in 5 minutes what are the next things that I want to talk about. What are the different ways by which you can perform experiments on CoAP? Use Puja simulator. Vishal is extremely good at Puja. Initially, he used Puja, submitted a paper with Puja, and that's where we got the feedback from the reviewers. This is good, great, but you need to perform experiments in real testbed. And we said, okay, we'll do it. So what is Puja? It's a built-in network simulator in an operating system which is called Contiki. And Vishal was using the word Contiki again and again. So you can actually install Contiki on your laptop. That's not a problem. And I think there's a live Contiki pen drive. So you can just install live Contiki on your pen drive, plug the pen drive and it will boot up. You can use Puja simulator. When you're done, remove the pen drive. It's a very popular IoT simulator to study mainly 2 protocols. There are many other things you can do. IPv6 in IoT also can be done, but CoAP and RPL. CoAP is an application protocol. RPL is a routing protocol. And more importantly, it has a drag and drop support in graphical user interfaces. So I have just taken a snapshot from the Wikipedia page of Puja. You can see these are the nodes deployed. And on the right-hand side, you can see the MAC addresses, IPv6 addresses, CSMA, and FE80::, that's an IPv6 address. So all of that is there. And actually, you can get power measurements, delay, throughput, all network important parameters can be obtained from Puja. So contact Vishal, you can have his email address, write a separate email to him, he can share all the details with you. Second, if you looked at carefully here in the implementations of CoAP, look at the left bottom, libcoap. That's a called library of CoAP in C. It's a C programming implementation of CoAP. And that also can be used. I will leave this slide for you to explore. If you follow this slide on your Ubuntu laptop even now, when I'm talking, it will just finish off your experiment in 2 minutes. So you can install the packages, download the libcoap library, install the libcoap library, go to one terminal, run coap server, go to another terminal, run coap client. Now take a look at this message which is at the end, coap client. Message type is a get message, and like Vishal said, instead of HTTP colon, it is coap colon. And what is this colon 1? Colon 1 is an IPv6 local host representation. You might have heard about loopback IP addresses when you studied computer networks. 127.0.0.1. 127.0.0.1 is an IPv4 loopback address. Same thing in IPv6 is called colon 1. So loopback because both your terminals are in the same machine, in the same laptop. If your server is on a different machine, client is on a different machine, then you have to use the server IP address here for the client to communicate to the server. And then this is the data that you are requesting, and this is also that Vishal was running again and again. He was putting sensor, pressure, accelerometer, all those things he was putting here and collecting that data. But the only problem with this particular approach is that you cannot model network characteristics because client and server both are in the same machine. So if you want to say, no, client and server should be separated by 10 milliseconds of delay, how can you model that 10 millisecond delay now? One is one terminal, another is another terminal. Where is a delay of 10 milliseconds between them? You cannot do that. Hence, you can use emulators. For example, Nest. I'll not go into the details of Nest. URL is available. I'll share my slides also. This is a network emulator that we have designed at NIT from scratch. There's a sufficient documentation about it. You can see there's a docs button. Source code is freely available. We have made it openly available. It's a free tool, openly available tool. Source code is also available. We have a mailing list. If you have any questions, you can come and our people will respond to you. So use network emulators. In fact, there was a different institute 2 months back. I gave 2 hours of talk only how to use Nest for coap experimentations. But again, these are all emulations. Finally, remote testbeds is something that I would recommend. Vishal already was giving you a walkthrough of FitIoT. We don't have too much time in 2 hours. There's very limited thing that me and Vishal can do. So maybe we'll be happy to talk to you if you are interested in these things and want to know more. There's another one which is called Flock Lab, which is in Switzerland, and it's from ETH Zurich. It's maintained by them. Again, that's a wonderful lab that my students have explored. But we found FitIoT Lab to be more user-friendly and more easy, and more support is available from their staff. So we tend to more frequently use FitIoT Lab. So I will stop my presentation here and would be happy to talk to the participants and know if there are any questions from their side. Yep. Was I audible, by the way, all this while?
Yes, sir, audible, sir.
Okay. I'll stop sharing and then pass on the control. So Vishal is here. I'm here. I know that this all information might be too much of information, but please feel free to reach out to us on our email addresses and we'll be happy. So I think there is some hand up. Do we want to take up the question? So there's a question by Divya. Yeah, Divya, please go ahead. I can see hand is up by Divya Vipin. Maybe she wants to ask a question. Or anybody else wants to ask a question, please feel free to talk. Thank you, everyone. I can see the feedback coming in the chat box. I'm glad that it was helpful. And we'll of course share the slides with Manish, my slides, and Vishal. You also had slides, Vishal, in the beginning, right?
Yes.
Sir,
Yeah.
sir, I have one question.
Sure, Manish.
This COAP protocol is available only with the Conti key?
No.
It's
no. It's available. It's available for many other operating systems. Like Vishal was telling, there's another very popular operating system called Riot, RIOT.
Okay.
So
okay.
You can use Riot. Another thing, Manish, you can just any operating system, whether it is Windows or Ubuntu or Red Hat or Fedora, any operating system you have, just download this library. I'm putting in the chat box. It's called libcoap. It's called Library of Coap, and its implementation is in C. So if you have a C compiler in Windows, you can work with libcoap on Windows. And if you have GCC compiler in Ubuntu, which everybody has if you are performing basic C and C++ experiments. Just install this libcoap library and you should be able to play around with libcoap in any operating system of your choice. By the way, I just forgot to mention, there is a very interesting framework if people want to explore. It's called IoTVT. And I put it in the chat box. So Vishal is right now, Vishal has, by the way, submitted his thesis. And now he's exploring even more wildly because this is submitted, so now he has open hand, so he's trying everything. IoTVT is a framework where heterogeneous IoT devices can seamlessly talk to each other. Heterogeneous IoT devices means one manufactured by one company, another one manufactured by another company, but still they'll be able to talk. So it's a very nice integration platform, IoTVT. And Vishal's entire PhD thesis is on Coax. He has proposed 4 optimizations on Coax, and he's testing those optimizations in live IoTVT framework right now. So Manish, if you think you or your team would be interested in testing out Coax, do reach out to us and we will be more than happy to assist you with that.
Definitely.
I want to add one thing to Sir's answer, that if you are good in Eclipse and like this, Java, then you can use the Californium framework. It is also freely available.
So that link, Manish, which I gave you, coap.technology/implementation, variety of implementations are there. Implementation in Python, Java, C, C++. So whichever you or your students are comfortable with, you guys can just get started with that implementation.
Sure, sir. Sure.
Okay.
Professor Mohit, my name is
do we have-
Prakash Vyavare. I retired from GSTI, but I visited NIT Surathkal long time ago when KC
Okay.
had organized some conference there. And I had a friend Shankar. I don't know whether Professor Shankar has retired now or is in mathematics department.
Professor Shankar is in mathematics department. He's there.
He's still there. Okay, so
He's there.
I just had one question about this nest that you have developed. You said this network stack, everything. So, I mean, this is a question not exactly to technology, but with respect to maintenance. You said you help people. I mean, so you have some project people who help.
Oh, that's a good question.
Because when the students, I mean, if we give this to the student, many students will, get interested and start asking questions. So, how do you manage this?
Yeah. So Nest is a platform that has been developed by our own students.
Okay.
And those students have now graduated, but they continue to be the maintainers of Nest, and new students have been onboarded. So we have a core Nest team which comprises of 13 students right now, including BTech and MTech. And we 13 people, including me, we respond to all the queries that come from the people. So we take care of the thing. And Nest started as a project for a 5th semester BTech group of students. And it continued on to 6th sem because they took courses with me in 6th sem, 7th sem, 8th sem. So they worked with me for 4 semesters. They took 4 different networking courses with me. And for each semester, their work was to keep making Nest better and better and better. And now it has become a full-fledged tool where we are recommending other universities to try and give us the feedback. Many of them have reported bugs to us. And that's why we have not made a stable release yet. We have just made a beta release. Our stable release is due, and first stable release will be made in December. And we have been already on it since last 2 years. It's an effort of 2 years.
So you are a co-author of the book with Stelling now. The cryptographic book of Pearson.
That was a work done by me quite long time ago. Yeah, with William Stallings, I was an author in one of the books. Co-author in the book. Yeah.
That's a great thing into that. And the last question is about this, like Flock Lab is by ETH Zurich, you said.
Yeah.
But what about this FIT IoT Lab? I mean, it is also...
It's in France. FIT IoT Lab is in France. And
but is it an academic institution or somebody is...
sorry, I did not get your question.
Like Flock Lab is ETH Zurich, which is an academic institution which is doing the work for it. So for this FIT IoT Lab, there are multiple organizations in France. For example, INRIA. INRIA is the most important body that's taking care of the FIT IoT experiments. I see.
Yeah. So INRIA is the leading one. There are many more organizations in France who have collaborated and they have received this funding from, I think it's called Fed for Fire. That's the funding. Like we have DST in India for funding and SERB for funding. So they have Horizon 2020 funding bodies, and there's a concept called Fed for Fire. And this is not the only one, by the way. If you have looked at Vishal's first slide, Fit IoT is just for IoT, but there are separate ones for Wi-Fi. There is separate one for 4G, 5G, and all come under Fit. Fit is Future Internet Testbed. That's the full form of Fit, basically.
Okay.
And IoT is just one of them.
Their literature is in English because the French problem, language is another issue that may come with the French people.
No, but I think all their tutorials and all their material that is available on the website is in pure proper English. There is no proper. Yeah.
Thank you very much.
Or in the mailing list, they can also answer your.
Yeah. We have been very actively using Fit since last 4 or 5 years, and we have got excellent support every time we have requested.
Mm-hmm. Okay, and what are the future plans of Vishal? I mean, he did not tell me here, but now you said that he has finished PhD. Maybe we will see him in Onria for postdoc.
Yeah, so he's waiting for his thesis comments, and in parallel, he has some offers for his postdoc. He's exploring those options.
All the best, Vishal. Thank you very much.
Thank you.
Thank you, sir. Thank you.
And thanks for the interaction. Thank you. Okay, I think I'll hand it over to you, Manish. I think there are no questions for us. If there are any, feel free to send an email to us.
So Vishal is explaining something, or is it just completed now?
No, I think we completed it because we overshot the time. So.
Good afternoon, sir. I'm Anjulata Yadav. I'm Dr. Anjulata Yadav. I'm associate professor in this department. Can you remember, sir? Myself, Manish Panchal, sir, and Anurag.
Oh, yes. I have met you in Jaipur.
NIT Jaipur, and you had given a wonderful session. You can say the practical experience on NS2. It was unforgettable session. Rather a workshop. Similarly, you had given just your can say highly commendable lecture today on this remote IoT test beds. So I'm really thankful to you, sir. So initially, Vishal Rathod sir has given us information about this Fit IoT lab, which is located in France at 7 different places, and what are the facilities which are available, how to proceed and run the experiments over it. And he has given the practical example of configuring the topology. And Mohit sir, you had given your knowledge about testing the protocols with respect to your mobility, cost, etc. And you had provided the knowledge about the methodology for the experiments, and then you have given the detailed overview of your COAP, that is the Constraint Application Protocol, that is about its working, about its layers, its message format, and the implementation of COAP. And you might have seen your chat box also. Okay, it's a wonderful session, sir.
Thank you.
It's unforgettable. I'm thankful to both your Vishal Rathod sir and your Mohit sir. Thankful, sir. Thank you, sir.
Thank you so much for inviting both of us for being a part of this whole program. Thanks to you and Manish. Thank you everyone of the organizing team.
I hope you will soon visit our college also for next session, for next workshop.
Definitely, I look forward to visit Indore anytime because I like your breakfast a lot. I enjoy your breakfast a lot, so I want to go. Okay.
We will be waiting, sir, for that day.
Thank you so much. Have a nice day, all of you ahead, and good luck for the rest of the workshop. Bye-bye.
Bye, sir.
Convey my regards to Professor Shankar. Vishal.
Definitely. I'll do that.
Yeah, my name is Prakash. Okay, bye.
Yes, sir. Thank you so much. Thank you.